Hello everyone. Welcome to another problem session. Okay, today we have a really standard problem, um, and rather than this problem, you probably more of a theory that goes behind this problem. But let's just do the problem. So from what's saying is we have a single source of sound, and you can do light, you can do other things, any waves. So that it goes through two slits. What comes on the other side, they are coming from the same wavefront, right? So over here, when this wave came in, it has this spherical wave. You can think of this spherical wave that hit that, but it's so big a sphere that it's just a plane wave. So we can say almost like a plane wave. Okay. And so these sources are actually, they have the same phase constants at over here and here, and they have the same wavelength, or we're going to use wavelength here, we can say same frequency. So this is mono, single frequency. Okay, so we don't have two frequencies here going, we just hit it with some sinusoidal. So the signal that comes in here to is sinusoidal electrical signal that's creating this. Okay, so this wave, so these two waves appear to be they've now become independent two waves. You might call it wave number one, and you might call this guy wave number two, and they are going to just spread out and various places in all this point in space, they're gonna overlap. Like the wave from here, wave from here will meet the wave from there, so they'll overlap. It's going to be overlap over here also. Wave from here will meet the wave from here, but we're not going to do experiment on every single point. We're going to do experiment over here. So take a point here, and you say wave from here has to travel that much distance, and wave from here has to travel a little different distance. And these distances being different, they were in phase here, and they are coherent. They have single frequency, sinusoidal, they're coherent, and they meet over here. These two, 1 and 2. I put a microphone here, and I want to ask what signal do I get, meaning I'm going to detect intensity. Detect intensity. The property I'm going to detect is the intensity of the wave. Okay, you can go through, we'll go through the math, or you want to see more math, that how to add this up and get the formulas, you can check out physicsbootcamp.com .org, so you can check out that website. Okay, so upshot is you are going to get a formula that at certain places intensity is maximum, max intensity, in the limit that we're looking at, when this distance is very far compared with the distance here. So L much greater than D. D is the separation between these two slits. In this limit, the directions in which you're going to see maximum will be we'll have this formula. So this we'll call it constructive directions. N lambda, or n can be 0, 1, 2, 3, etc. So just looking at the positive angles, say these positive angles will be like that. And of course, by the symmetry, if you're looking along this line, the direction below that center line will be negative, and those will be negative direction will be -1, -2, -3, etc. Basically integers. N will be integer. Mean intensity will have very similar formula, but we're going to call it theta destructive, and it's going to be, I'm going to use letter M, not mass, just letter M. M times lambda over 2, and this M will be odd integers. So for the plus, you're going to have M equals to 1, 3, 5, 7, etc. For minus, it's going to be -1, -3, -5, -7, etc. So these are the formulas that you're going to derive. You can study some theoretical thing, and maybe you, if you get time, you might drive it today itself. But right now, let's try to finish in answering the question. So you can see that from here, already you can see, let's look at this formula a little bit closely. It says sine theta c will be n lambda over d. And because this is sine, this has to be less than or equal to 1. Sine cannot be more than 1, right? For the positive part, and for the negative part, it has to be greater than or equal to -1 for the negative parts. So there is a range of angles. Let's put it like this. There's a range. If you look at this angle, you're only going to get this formula is applicable only in this range. Okay, so this is the like a theta c max allowed, so to say. So that's how we'll answer the part 2, and part 1 is just basically using these formulas. So we are supposed to get 2 positive angles for theta from this and from this. Of course, n equal to 0 is not positive, so there's a one directly here, constructive. So there's a constructive here, so we'll get a constructive 1, and we're going to get some constructive 2, and in between will be destructive. It's the way the formula works out. Okay, so we're basically looking for answer n equals to 1 and 2 from here, and we're looking for answer m equals to 1 and 3. So for the constructive, I get this theta c will be arc sine inverse lambda over d for 1, theta c 1, and theta c, the second one, will be 2 lambda over d. And so let's find this guy out. So arc sine inverse lambda over d is lambda at 10 centimeter, and this is so they're in the same units, so it just becomes 1 over 3. Over here, I guess arc sine inverse 2 over 3. And so thus for the constructive. For the destructive, you can see theta destructive 1 is going to be arc sine inverse m equals to 1 So 10 over 20, so 1 over 2. And then theta destructive 2 will be arc sine inverse 3 times. Now this is going to be 3 times 10 over 2 times 30. So see, this is going to be 10. 1 times 10 times 2 over 30. So this is actually 1 over 6, not 1 over 3. This will be this. So this is arc sine 1 over 2. So this is solves one, these two, and you can just plug in a calculator and get angles. To get the 2, to solve 2, I just said this this has to be less than 1, so this has to be less than or equal to 1. So that will be n max. So n max has to be less than or equal to d over lambda. So that's 30 over 10. So n max has to be can be 3 only, and has to be integer. If it's not an integer, I'll have just truncate it. So truncate it if not integer. Say you got d over lambda equals to 3.6. What you do? So this will mean it will not round up, it will just become 3. 3 will be the answer. You just drop the decimal. Our so-called floor function. So this is like a n max equals to d over lambda, take the floor function. Okay, so this solves the problem, but then the question comes, where did I get these formulas? And I think already I'm kind of 12-13 minutes in explaining this problem and solving it. I will send you to this place, and maybe next time I'm gonna talk about diffraction. Maybe I'll have one full lecture just talking about the math part of this where the formulas comes from, right? A lot of times when you're asked question about interference, they really don't care about how you come up with these formulas. They care about where just using these formulas correctly. Okay, so this should help. I will if you like this video, just hit like and maybe tell your friends, subscribes to this channel, etc. So talk to you later. Bye.